How's it going, everyone? We're getting set up here. We're going to figure out what went wrong yesterday. We had a problem yesterday. Yesterday, we had a problem where our AI model wasn't learning. You can see here our loss had an issue. You can see right there. What you're looking at is a model that's not learning anything. And there's a problem, and we're going to figure out why. We're going to figure it out. I did look into this a little bit. I think it's actually our data. However, before we do that, we had some recommendations. We had some recommendations here that took us into learning about a potential mistake that we made in our model. That was right around over here. Okay. Try hard. Oh, try hard. Okay. Found it. They said something with the loss function, activation function. Turns out the loss function that we're using doesn't require us to use a one-hot encoding. We can use hey, first Claude here. Good to see you. How's it going? Welcome on in. Happy Thursday. Good day. First, yep, you're number one. You made it first. Good job. First, like, done. You did it. The value wasn't familiar with the loss function of the Pytorch, so it says that the sparse categorical loss entropy and categorical cross entropy, you don't need one hot encoding. Now, we're not using Keras. We're using Tensor. We're using Pytorch. How are you? You don't? Oh, how are we doing? We're doing great. We had ate some food, did a whole bunch of meetings, and now we're ready to stream some Pytorch. I'm excited about this because we've got, basically we wrote everything. We wrote it all. It's all there. Claude, I'm also very excited about your game. Once you get your game, I want to play it. I want to see what you're doing. Over there. So for your code, it should work if you remove the transformation for the hot encoding. Okay. I understand, right? The sparse categorical means that there's just a few categories. In that case, with AI, typically you like small numbers between 0 and 1, right? -1, +1. Keep in that range. Very small numbers. However, it can reach outside those numbers and still function okay. It can go up to like maybe around 100 or so, although you're reaching once it reaches 100. Like if you go beyond that, now you're running into problems. You're hitting some issues. You have one startup idea? Brainstorm. Okay. So if you share when ready, will you see in meeting on your available time? Yeah, sounds good. Yeah, let's do it. Claude, absolutely. Do you have the calendar invite link? We could set up, just send me a direct message and we could set it up. I think that'll be great. A direct message sounds really good. Okay, let's keep going here. So I'm going to try this. I'm going to test this out. I'm going to see if that's the case. I don't think that's the problem because this should work either way. It should work with one hot encoding and it should also work perfectly fine with a sparse categorical single value. We could do that. So we could remove the one hot encoding. I think, well, is that going to fix it? I don't think so. So we're going to find out. Let's try this here. Okay. So here is the current loss. Current now is not ready. Okay, whenever in the future ready at the time, I'll sure share it on DM. All right, sounds good. All right. Happy to hear it. Okay. All right, so here's what we're going to do. We're going to walk through this, and we're going to see if we can figure it out. So as you can see here, the loss, it maintains its state. It stayed at, right here. I'm looking at this number right here. That column, it stays the same, roughly the same, right? Around 2.3. We need it to start reducing, which means the loss is going down, which means the model is more accurate. We need to improve this. It's not working. So one of the ideas was to remove one hot. Okay, I'm going to update the Discord thread here. We are trying this now. Okay, we'll remove the one hot. There we go. Remove the one hot, perfect. Also getting error with WSL Linux, like the GUI is not opening in Windows 11. Will you guide me? I don't use Windows. I've never used WSL. I'm from the age where Windows subsystem for Linux didn't exist. I have no idea. I am a Linux or a Mac. I'm running on Linux or Mac. That's where my expertise lie. I haven't used Windows for so long now. How many? It's been like 20 years. I've seen it. I've seen Windows. I don't even think I've run into a computer that was running Windows at other people's houses. That's as far as I go. I don't know. I don't know beyond that. Okay, so where are we at right now? Where's our data? Okay, so this is our data set. I think the problem is in our data set. However, let's remove the one hot here. All right, let's make our way, you guys. Let's make our way. We'll make our way. We'll make it happen. Okay, where's that at? So one hot's right here. I think we could just remove that and it will work automatically. So we just boom, boom, like that. Okay, so that should let's validate that that's gonna work. That's gonna give us what we want. So we need to get the we need to print the predictions. Print. Oh, we also wait. No. There's something else we got to do. We got to turn this over here to 1. Okay, so that's the categories. So let's do self.categories equals 1, and we're just gonna set this over here. Here we go, like that. So that way we know that it's gonna be one category. Well, essentially, it's more than one category. It is. It's more than one category. It's just that the number of outputs is what it's gonna be. Hi, Derek, good to see you. Welcome on in. Thank you for saying hi. Happy Thursday. We're gonna solve the problem that we had yesterday where our AI model wasn't learning. You can see right here, we had some issues. You see the model right here. Check this out. It's not learning. It's all the same. So let's fix it. So what should we output? Let's just change. It's outputs. I'm just gonna change to the outputs. It's a little more on exact. The outputs are the categories. Don't get me wrong. That's what they are. But there's just one output value, and it's gonna be a linear value. It's gonna be a linear value, which means that we cannot have a sigmoid or a tanh here. So sigmoid, like this. That won't work. So we have to comment that out. Game is on pause for some of the time. Getting a major stuck bug, so fixing it whenever you're ready, then you'll be ready. Okay, got it. Sounds good, Claude. Appreciate it. Understood. Let's try this, you guys. Let's try it. All right, so we got rid of the transform just temporarily, so we disabled the one hot right here, and we reduced the categories. So let's print out the prediction. All right. And let's print out the actual label, which is going to be Y. All right. So prediction. I'm going to put this into an F string so that way it's easier to understand what this is. Like that. Using NeoVim looks like magic. Hey, Mufti Cactus. Welcome on in, Mufti Cactus. Yeah, we're using some Vim over here, right? We use regular Vim. So this is standard Vim. Well, NeoVim is also basically the same. They're the same thing. NeoVim is a fork of Vim, and it just includes Lua as a scripting language. You don't need that though. You can stay on standard Vim, which is where I'm at right now. I like my standard Vim. Other people, Sigma male, Python people, Sigmoid. Yeah, Sigma versus Sigmoid. Sigma or Sigmoid. I like the Sigmoid. Good activation function, right? It's a non-linear activation function. It's great. Okay, so, and you know what? I remember this. I don't know if you know this. Remember in early elementary school when you were learning various functions that are available within math, right? On linear calculations, you ran into cosine, sine, and tangent. You remember those? Well, it turns out one of those is going to be used. We're using those. Tangents and things like that are actually used in AI. All right, so prediction equals like this, and we'll do the same thing over here for the Y. You know, actually, we could just do it like this. I like this better. Let's do this. We'll say Y like that. Y equals. So that way we print this out. All right, so now we know. Now we know if it's looking the way we want it to. So this is going to confirm it. Okay, we're going to try this. Let's try it now. Wait, let's close that and open this over here. Okay, let's try it again. Morgan, good to see it. Wait, hold on. Was that what we wanted? That is the batch. Oh, that's the batch. Got it. So good news. It looks right. So that would be the Y equals the batch, and the others is the batch here. Okay. So it is a number. We're looking good. Hello, Steven. Can't watch the stream today. Bye. Okay, Morgan. Thank you for stopping on by. All good. Use less phone because life cycle of OLED screens. Oh, yeah, got it. Okay, yeah. The OLED screens, they've got burn-in. They've got burn-in, you guys. Hey, Sky, good to see you. Welcome on in. Happy Thursday. Let's keep going, you guys. Let's get going. All right, so I do believe this is what we wanted it to be. However, I think I want to do 0 like this. Let's do 0. So that way we can see a little bit better what it looks like. All right, let's look like that. All right. Now, we're going to Python that. Okay. Yes. Okay, that looks correct. That looks correct. So this means that we've got rid of our 1 hop. Although I want the 1 hop back, guys. I want it back. This gives us the output. And then what we need to do is when we're comparing the loss and the output, we need to tighten that up, right? How do we converge on the actual answer when it's in this linear format? Do we do a round? I think we do a round, right? We round it? I'm pretty sure we round it. I think that's the answer. You round it. Now let's focus on the coding, bro. I stopped chatting for a few moments. All right, no worries. It sounds good. We're gonna do the coding now. Okay, so we don't need that anymore. All right, so I do believe we did the trick. Now let's go ahead and run the learning. Let's see if it works. Did we do that right? Why is it 0? Wait, hold on. That seems weird. That seems weird. Here. Loss, colon. It can't be 0. It cannot be 0. It just can't. That doesn't make any sense. Hold the phone. Why is it? That's not right. No way. Okay, hold on. Let's see. Our learning rate is good. What if we reduce the learning rate a lot? Okay, let's try that. It's loss of, it cannot be, it's not that smart. There's no way. Okay. Hey, Steven, I'm thinking of changing my domain from web dev to an AI engineer. What do you think? AI entertainment, you should do it. All right, because we're in this new world. Although, good news. I'm thinking that now that we've got AI that writes all the code for us, we're going to see a lot more engineers pop up in the world building things that they don't want to maintain. You're going to need to help them maintain it going forward, right? Because they're building all this stuff, and it's still a lot of effort to do, right? You still have to spend a lot of time on your computer making it happen. So from my perspective, I think that makes a lot of sense to go into AI. Why not? We should do it. Make it happen. At least start it. At least start, right? And if it's something that you want to do and it's going to make you happy, do it. That's what I say. I think you're on the right track. Make it happen. All right. Why is the loss being weird? Should we do like a round on this? Can we do like a round? Is there like an in.round? Will that work? I don't know. I've never done that before. I'm not familiar. Round. All right. So let's see here. Activation. Let's look this up. All right. So Pytorch round activation or something. A round layer. And Pytorch, the standard function for is Tensor round. However, directly using torch round as an activation function in a neural network is problematic because it's not differentiable. It breaks the gradient chain, the backpropagation. Okay, we can't do it. Fine. All right, we won't do it. We won't do it. Hey, Mufti Cactus, what is going on? I've been watching and got no clue. What is he training something? Yeah, we're learning. All right, so check this out. We are going to become Pytorch tutorial X. We're going through all the Pytorch tutorials, and we're going to become experts at Pytorch, right? AI, machine learning technology. It's a framework for training AI. The one that we're using right now gets this data right here that you see on the screen, and it's going to have a bunch of pictures. And these pictures we're going to pass through a neural network, a deep learning neural network, that will understand how to recognize each of these things, right? A sneaker, a bag, a shirt, another bag, another shirt, a dress, a sandal, those sorts of things. We're going to train a model on this. Some computer vision is what we're doing. Thank you, Daisy, for saying that. Good to have you here. Welcome on in. Happy Thursday, you guys. Happy Thursday. All right, let's keep going. This is what we're building right now. So we already wrote our custom data set. We wrote the model. It should all work. However, the plan for the end of the stream, before we end stream, we have to at least get this working as best as we possibly can. That's the plan. That's what we're going to do. All right, let's get going, you guys. All right, so we are currently at, today is also GitHub Rubber Duck Thursday. Is that a thing? I didn't know about that. What is that? Tell me about that. Tell me more details. I've never known about that. So we're right here at the optimization phase. So we've gotten through a lot. We've gotten through a lot of this. We're almost there, you guys. We're almost there. So I want to make sure that we're getting it right. Okay. What is odd is this is being very weird. So I want, why is, are we doing the right, are we doing the right loss? I feel like MSC makes more sense right here since we're doing a single value output, right? Since the output is single value. Hey again, web dev to AI guy. Sorry to bug you. Any tips from where to start? Yeah, I like computer vision. So if you're familiar, there is a Pytorch Keras tutorial right here. I'll paste it on our Discord. It's really easy. Very little bit of code right here. I'm scrolling through it. Done. That's it. One page. Easy. And you'll do, it's a optical character recognition, OCR, right? Computer vision tutorial. And it's a really good starting place. I think it's a good one. The Rubber Duck is a live stream of some project. Oh, that's what that is. Okay. I didn't know. We're learning new things. Thank you, Claude. Appreciate it. We're learning some, oh, input shape. That's why your flatten never worked before. Oh wait, this is Keras though. That's Keras. Okay, we don't have to worry about that. I'm getting the syntax mixed up. Okay. So we are in the right spot now. We've got everything looking good. The only thing is now the loss is too good. There's no way it's that good. So outputs, I think, okay, so what was we needed to do? Oh, I think we need something else. I need like MSE loss or something. Let's do nn dot mean squared error loss. Can we do that? Is that something we can do? I think that's what we need to do. Let's try that. MSE, was that, it didn't, that's not a thing that exists? Where's the issue here? Let's figure this out. MSE loss. Oh, wait, why is that that should work perfectly. MSE loss out MPS only defined for floating types. Isn't that what we have? We have floating types. This is the Rubber Duck Thursday. Oh, got it. Cool. Thank you. I'm just kind of curious. I'm going to click into it real quick. Oh, it doesn't start yet. Oh, it started already.
Available on here then.
Nice.
It's something you just have to highlight it, and then it's automatically in.
Neat. Okay. Thank you. Thank you for the reference. I appreciate it. Okay. Let's keep on going, you guys. I am interested in figuring this out. What did we do that's weird? What was the problem? So let's hide this really quick. Let's make sure that we didn't break anything. Okay. And that will MPS. All right. Looks good there. All right. So then let us call a break here. Let's just return. We're live debugging, you guys. We're live debugging. Okay, there's no problem there. So this is good. Let's print this out and make sure that everything looks nice and tidy. Oh, wait. Why did that print? Wait, whoa. Hold on a second. Why did that print out a bunch of stuff? That doesn't make any sense. It should have printed out just one thing. Hey, Darden Theon, thank you for the 100. I appreciate it. Thank you for sending over the 100 there. Some jewels. My gratitudes to you. Thank you. It's a nice gift to give out on Thursday. I think that's very nice for you to do. Appreciate it. We're figuring this out together, you guys. We're going to figure this out together. We're going to learn and make things happen. What? Music change mood. Oh, yeah. C in positive. BG music gives it feel like we're solving a mystery of coding. We are. That's what we're doing right now. We are trying to solve it. This is weird. Look at this. Why is it doing this? What's happening? I don't understand. Why is it printing out 5 things? It should only print out one thing. Right there. It should print out one thing. Just one. Oh, no, because it's 5 epochs. Okay, never mind. I know now. All right, that's 5 epochs. All right, we figured it out. Don't worry, we figured it out. No problems here. We're going to also learning artificial intelligence. Currently working on building an Wordle AI to find the best playing strategy. Best of luck. That sounds like a really good project. Hey, Mufti Cactus, great project. That's a good one. You can do it. It's possible. There's got to be a trick to it. There's got to be a way to like reduce your errors. Getting the best Wordle. There's got to be something like if you're gonna look at all the past data, and then you're gonna do some randomization in there, and then you're gonna try to track down which letters make the most sense across all the different puzzles. This sounds like a fun project. Okay, so this looks good to me. It looks perfectly fine. So wait, MSE, why did that fail? Is it gonna, oh, because the error, okay, so it's gonna fail right here. So when I return here, it's gonna fail right here. Okay, that's where it's gonna fail, okay. Let us look at the mean squared error Pytorch. All right, let's make sure we're doing this properly. MSE loss. It's MSE loss right there. Reduction mean, reduced none, average size none. That should work perfectly fine. Why is it not working for me? Why is it not working for me? And that's not fair. It's right here. All right. Model.loss prediction. All right. Let's comment that out. Let's try that. 5G speed. That's pretty good. I'm getting 6.2 gigabits. 10 minutes with your live stream running. Wait, a 6 gigabit file with 5G? You should be able to download that within a minute. You should download that in a minute. MSE loss output MPS only defined for floating types. Everything is floating. It's all floating. Everything is floating. Oh, wait, no, it's not a float. Okay, oh, the output isn't a float. Okay, we need to convert the output. Right. Because before, look right here. This is not a float. That needs to be converted to a float. Okay. So we could do that. We can do that here. Let's do that. Float. Ah, there we did, right? Easy right there, right? Okay. What games do you play? Minecraft. Old ways again. Good to see you. Welcome on in. We like Minecraft, you guys. All right, float label. So now it should work. All right. Hey, Night Hunter. Night Hunter Crazy. Good to see you. Welcome on in. Happy Thursday. Ooh, look at that. Look at that right there. Oh, it's not a tensor anymore. It's not a tensor. Okay. So label needs to be a tensor. All right, so let's do this right here. Torch dot tensor, comma d type equals float. Hey, there we go. Now we don't have to do anything special. All right, now it's a tensor. There we go. 3 gigabytes in just 3 minutes. All right, a gigabyte a minute. Well, that's still, I think you're pretty. Hey, Foz. Well, hello. Thank you, Faza. Good to see you as well. That's very nice for you to say. I like your session very much. Night Hunter Crazy. Great. That's good to hear. We are debugging together. We're going to become Pytorch experts. So right now we're going through all the Pytorch tutorials. We're going to go through every single tutorial. We are almost through all of the basics parts. So we're at the tail end here. Tomorrow we'll get to save and load, or today we'll find out. And then we're going to move on to the next tutorial, and eventually we're going to start building some projects, and it's going to be a lot of fun. We're going to get into day trading, algorithmic trading, different ways to get the AI to optimize on certain patterns for us so we don't have to optimize. The AI will do it for us. All right. So I think we fixed that problem. Let's see if it works now, you guys. Let's see if it works. Oh no, why is it not working? All right, we'll figure this out. We will. Oh, it should be working. It should be right here. Why? This part right here is perfectly fine. Okay, so, all right. So it's your birthday tomorrow, Jin Lu. Happy birthday. My back hurts. That's it. Jin Lu, it's good to see you. It's starting to give up already. It already happens. It already happens. I know, it's us sitting down. It's sitting down. So you just have to have good posture. Sit, focus right on your screen, and don't move. That's a trick. Don't move too much. So why did the two device fail? Why is that failing? Right here. Okay, so let's double check. This is good still. Okay. No, Mufti. Oh, hey. Okay, so we got a thing. Okay, where is this? Oh, wait. We can't do it. We can't turn it into a tensor there. We got to turn it to a tensor somewhere else. Okay. Let's do that. Let's not turn it to a tensor where we thought we wanted to turn it into a tensor. Where do we put that at? So we are going to right here. Oh, wait. Redo. Okay, let me save that again real quick. Double check, you guys. Double check. Okay. So we have to do this differently. There we go. We will turn it to a tensor later. Let's turn it to a tensor right here. Right here. Okay, so we're gonna call this a torch.tensor. Kind of feel bad because every time you have an error in your code, you always give it to AI instead of trying to fix it yourself. I know what. We could fix it right now with AI if we wanted to. The struggle is what you want to give yourself the opportunity. I know it's painful. You're right, it's painful. It's worth it though. It's worth it because it teaches you, it learns, it triggers all the neurons in your brains to build up. That's the struggle. You gotta have the struggle. You got a good sitting posture? You had, oh, that's terrible, Jinlu. Oh, so you couldn't sit? Okay, understood. Torch.tensor, comma, D type equals float. And is it a tensor like that? Hold on. Python import torch.tensor. That's a method. What about a capital tensor? Capital T, please. A capital T. Oh, wait, we want the lowercase one. Let's do a lowercase one because I think that's better. Yes. What if we do a capital one? What's that gonna do? The same thing. Oh, there I did. Oh! One automatically converts it into a float though. So we could just do a capital because we don't need to worry about D type. Let's do that. Let's do that. All right, tensor D type. We don't need D type anymore. So it makes our code. See, that's what we learned. Is this Godot? Hey, Ashlyn Orion, good to see you. Welcome on in. Happy Thursday. We're doing Pytorch. We're going to become experts. Let's become experts together. The plan is we're going to go through every tutorial on Pytorch. If you ask AI to get direct answers, you've got to go through the wrong answers for learning. Yep, you've skipped all the wrong answers is what you've done. You're having the AI do that for you, and you won't get to learn the wrong answers, which I think, me personally, is one of the best ways to learn. You want to learn all the wrong answers. That helps you create a foundation about where to move next and how to build up that knowledge. The wrong answers are important. You went to school, sat down in programming class, and you literally couldn't write more than 2 lines of code before you started feeling bad. Oh, no. Oh, hey, you're not... Okay, Jinlu, stay well then. Be well. It sounds like you're in a spot where you gotta relax and be well. Mr. Nomad, thank you for subscribing. Welcome on in. Good to have you here. Happy Thursday. You joined the right channel for software engineering. We are building Pytorch. We've got a problem with our model right now. As you can see on the screen, there's a problem with the model. We're going to debug it today. Before we end stream, we will get a model that learns. That's the plan. We're not going to stop streaming until we fix it. And the good news is we do have time for that. Though I want to fix it as soon as possible. Yeah, I'll take it slow, not too uncommon around by birthday. Okay. Got it. Okay. Keeping it slow and easy. That's the way to do it. That's my favorite kind of day. A slow and easy day. Just sitting back, maybe a little bit of Minecraft, sleeping. Yeah, that's right. Let's go to sleep. And I like sleeping. Okay, so that should do this part here that I want. ToTensor.toModel. Let's try it. Oop, no. Oh, no. Oh, yes. Okay. Let us see if that works now. No, we still got a problem. All right. Only defined for floating types. We've done floating types. We converted it to a float. It's a float now. Train epoch. Call self-implement. Oh, right here. So it's having a problem right here. Okay. In the loss function. We'll figure it out. It also falls on another Friday the 13th. Oh, yeah, that's right. Hey, wait. So I'm crazy. Were you actually born on a Friday? The last time it's more it's more impactful if you were born on a Friday, because most 13ths are not on Fridays, right? 2 week lockdown. Oh, the 2 week lockdown. I remember that. Okay. Why this not work? try that real quick. See what happens when we do this. Okay. I expect more. I expect the error. Yep, that's right. It needs to be on the same device. dtype equals float. Let's go. Let's try this. Okay. How's it going there, HS? Welcome on in. Good to see you. Happy Thursday. Can I convert an MPS Tensor Float 64 to the MPS framework? Doesn't support Float 64. Try Float 32 instead. Fine. Okay. 32. Wait. Float. NN dot. Float 32. Okay. Let's see if that works. All right. No float 32. What about a 16? Is it types or something? I forgot how to do this. I don't do this that often. So right, part of becoming an expert. All right, float. Torch.float. Yeah, all right. Well, is there a different kind of float? Are there different? All right, so Torch supported float types. How's it going there, Pasavara? Pasavara, good to see it. Float, half. Oh, there's a half. Right here. Float, torch.half. Let's try it. Let's try torch.half. I like that. All right. Torch.half. Okay. .half. Torch.half. Okay. How about now? Is it going to be working now? Oh, it really doesn't like that. Oh, nope, not that one. Not a good. Oh, we caused Python to crash big time. Look at that. Okay. Don't use torch.half. Do whatever you do. Ignore. Wow, that crashed it big time. Be careful, you guys. Whatever you do, don't use torch.half. It does not like it. Whoops. Okay. Only defined for floating types. I know we are. It's a float. I swear. Okay. Y equals Y dot. Let's do this. Right here. This. Okay. And then we say Y equals Y dot to device. Let's do this. Right here. All right. Okay. And then we will try. All right. So now, instead of putting it on all one line all at once, we're going to put it multiple lines. It crashed so hard, macOS had to intervene. It did. It crashed really hard. Okay. Let's see if we can get that one to work now. Let's try this one. It is a float, you guys. It is. All right. Print Y. We'll print Y each of the stages right there. Y, and then we're going to return before we go down to the picture here. We're doing some debugging, you guys, some debugging. Look at that. That is not a float. It isn't a float. All right. So can we do this? There we go. Let's convert to a float. Hey, Steven, how are you doing? We're doing good. It's still not a float. What happened? We're doing great. Thank you. Shyam, good to see you. Shyam Gurunath, good to welcome on in. I'm doing some debugging too. HS, let's debug together. That's what we're doing right now. We're debugging together. All right, torch.tensor, comma, dtype equals nn.types. How do we set a type here? I don't do this that often. Oh, maybe you guys. There is a file that we've already got around here somewhere that has done this. Tensors, here we go, tensor. dtype. But we should do, torch.beef, so float 16. Okay, so we can just do this. Torch, it's just torch.float 16. It's just torch.float 16. It's really easy, right? That should work perfectly fine. dtype equals torch.float 16. There. Now are you happy? Are you happy now? We're gonna find out. Always the cool stuffs. Yeah, Loons, good to see you. Welcome on in. Thank you for joining again. Good to have you back. Always the cool stuffs. You got it. All right, let's make sure this works here. Let's close this. Bring this back over here. And then check our place. Okay, now it's a float. We're good to go. Now it's a float. And it's a batch, right? So we've converted it into a float 16. Good. Let us check this over here. Do we have to do that with X as well? Maybe do X. We don't have to do that with X as well. I don't think. All right. So, are we going to get a different error, or is it going to work this time? Oh, another hard crash. Another hard crash there. Ignore. We're trying our best. All right, float 32 then, maybe? Okay. How about that one? Okay. It's different now. Invalid. Oh, okay. Fine. Like that. Is that better? Let's just double check that we got everything right. Tensors. Yeah, okay. It's torch.tensor like this, right here. What are you building, Sim28? Good to see you. What we're building is we're building the Pytorch tutorial, which should be really easy. However, we believe that there's some problems in the tutorial. We actually ran into some actual problems in the tutorial. We've got everything perfectly fine. Fine tuning, bro. Pasavara. Good question. That's a really good question. We're actually just trying to do something really simple. It's actually a tutorial. It's a tutorial item. We're trying to get this data here, which are pictures of images, and we're going to classify them using our classifications. There's 10 different types of items, and we're going to train the model on it. We should be able to do it. We've got an accelerator, right? We've got an accelerator. We've got MPS. We're good to go. So we can use that power to deploy on our accelerator all this image data. And it allows us to train a model quickly. So this is what we're building. This is what we're building right here. Let's make our way. The float 32 D-type right here. Okay, let's try this. Is it going to hard crash again, or are we better now? Oh, there it goes. Okay. Oh, thank goodness. Oh, I'm feeling so much. Oh, wait. Warning. Something about a warning. All right, lost, blah, blah, blah. All right, so we're using MSE. It's learning. Oh, it's actually learning? Oh, wait, no, is it? No, it's not learning enough. Okay, I think there's another problem. We've run into another problem. Okay, that is not a good learning. That's not a good learning. But we at least we made progress. Look at that. Stephen, hope you have a good, worked with WebRTC. Yes. Getting confused with stun and turn and ice and stuff. Okay, so the stun server, so the stun server and the ice server, the ice candidates, right? You need a broker of sorts. Normally, if you don't have a double natted computer system, right? So you've got a phone, you've got a computer, and you're running on a normal home network, you're typically natting because you've got a lot of devices on your home network. So there's a network address lookup table that converts all the ports that are currently being used for devices locally with outbound ports on your router. So that way it can reroute all that data on your device, which has a local IP address. The problem is you want to connect directly with another device for WebRTC because it's peer-to-peer, right? WebRTC is peer-to-peer. You need to be able to find a traversal when you're trying to send packets between each other. You need extra information in the packets for routing because it's peer-to-peer. It's not like a server-to-server. So you still kind of need a broker to at least establish part of that routes. And you can use something like a stun server to capture, or right, it was an ice server. It's one. So there's two types of servers. One is a full broker where you upload all your WebRTC data and all your video data to the server, and that server would then retransmit it to the other party. That's a full broker. That's a full server solution. That's like an MPS, a multimedia processing server. There's another kind of server that only is needed at initialization. And I believe that is it's a turn or stun server, right? So I think it's, let's look that up really quick. Let's look up the differences. So stun versus turn, right? Session traversal utilities for NAT. All right, so stun is going to be the first one for connecting devices directly. You need that so that way you know where your IP addresses are, because you don't know each other's IP addresses. You just need to be able to find a route so that way you can communicate to your router to transmit that data directly to the target device. And that target device also probably has a router as well. What is a WSL SSH server? Windows subsystem for Linux SSH server. You're probably going to be an SSH client and an SSH server. So the SSH server is going to be running on your WSL. It's going to be listening on port 22. And it's going to be listening for inbound requests to establish a connection that's secure with a public-private key pair, right? Or maybe a cipher key, like a password and a username. You could do that as well. The the idea, so jumping back over to WebRTC, the turn server is, I think, relays directly around NAT, which I believe is the full broadcast. And you really want the stun server to be working because you want to get those ICE candidates, because you don't want to have to spin up and host a lot of bandwidth. Okay, got you. All right, cool. Stun discovers public IP addresses for direct communication. Efficient, low latency, while the turn acts as a backup relay when direct connections fail. So if you want to make this available to the whole world and bring into the whole world a full solution for WebRTC, you need both. Really depends though. It really depends. Are you trying to do straight peer-to-peer communication? Then you really only need the stun server. Right? The turn server is going to be a heavyweight and expensive. Good news, Google and Cloudflare and a couple others already have free public stun servers. So you don't need to set those up for yourself. You can just hit one of those stun servers. It gets you the ICE candidates that are necessary in order to communicate directly with other candidates that traverse through NAT. Because you're going through NAT, right? Peer A is a phone running on your Wi-Fi. Peer B is someone else's house or business running a laptop, for example. And you need to get connected to each other. That's how that works. I don't know. Is that a pretty good, is it like a lightweight description? I feel like it's pretty straightforward though after that. All right. So let's look at our loss here. Our loss, here's, look at, we at least fixed it a little bit. Oh wait, hold on. To copy we've got a problem. User warning, to copy construct from a tensor, it is recommended to use source tensor detach. Oh. Do we need to do that? Where's that happening? What line? Line 103. Okay, line 103. Oh. Why? Wait. Is Y already a tensor? Print Y. Return. Is Y already a tensor? Did we mess that up? Are we doing this wrong this whole time? Okay. Yeah, so good. Nice. All right. It is a tensor already. Okay. We're just trying to double tensor it. That's why. Okay. So, whoops. Sorry about that. All right. We can fix it. Select forward unit is in WebRTC. It's not peer-to-peer. SFU. Selective forwarding. Okay. Yeah, there's two types. As far as stun and turn. With the turn, you're probably dealing with SFU in that case, is my guess. What kind of loss function is it? We got it working with the MSE because we don't do cross-categorical because it is a sparse cross-categorical. We can do MSE instead, so it's no longer one hot. Steven, my dog is going there. The infamous. Good to see you. Welcome on in. Happy Thursday. Let's fix it together, you guys. Let's fix this together. Okay, so it's already a tensor. So where is it? Let's see here. Let's go back up here. The label is already a tensor right here. When did it become a tensor? Oh, it probably got converted to a tensor over here. Shouldn't this be a tensor? I feel like this should already be a tensor here. Like right here. So it is. So when we get an item, this already is a tensor, right? Image directory, get item. So we load the item, we get the features, we get the labels, decode. That's the features in the image path here, in the data. Where's the data at? Where's the data? Hold on. Wait. Oh, this is coming from a CSV. Okay, got it. Okay. So that cannot be a tensor. It cannot be a tensor. It's getting converted to a tensor in our data loader. That's what's happening. I think that's what's happening. So what we should do is we should convert this to a float right here. Right here, right? Float like that. Can we do that? Is that going to be better? I think that'll be better. So let's do this. Let's try this. Okay, let's see if that works. Let's see if that works better. Can you check out LiveKit, Steven? So cool. Lot of protocols. LiveKit. Yes, I've heard about LiveKit. Let's check it out real quick. LiveKit. If you're doing WebRTC, there's an easier approach. You could do WebRTC, SDK, JavaScript, GitHub. And there's a good option around here. Oh, wait. Hey, look at that right there. I wonder who this person is. Right there. This actually works really good. I like this one. And it's free. Supports photo, images, WebRTC data, receiving calls, multi-party calling, audio-only calls, broadcasting mode, instant connection dialogue, and it includes automatically all the stun servers. Yeah, it gives you all the stun servers for free. So if you want to go with this, you could also use LiveKit. That also works. I think there's a pricing though. It's cost money. You should use the free option. Use the free option. Here, I'm going to paste it into our Discord. Paste it into Discord. So I will go over here and say our link share. There you go. Link share right there. It is a free option. Yeah, no, I built it. How many years ago now? That would be, wow, 12 years ago. We're old, you guys. We've been doing this for a while. Okay. Let's keep going on our AI model. I think we're going to figure this out. Okay. Let's print this. All right. Let me see here. Okay. So, cannot convert MPS tensor float 64. Okay. Please use float 32 instead. Got it. So, right here is when we need to make it a float 32. So, I believe, can we say torch.tensor D type equals float 32. Wait. Torch.float 32. Okay. Let's try that. Although that's the same thing. You know what? It's not though, because it's not. Okay. Let's try it again. There we go. There we go. That's what I'm looking for. Right there. Okay. Okay. So now I believe with the data loader now not coercing for us automatically the integer into an integer tensor. We coerce it ourselves with a direct type conversion right here into a tensor of float 32 type. Meet you tomorrow. All right, sounds good, Claude. Appreciate it. Had to eat. I'm back. Hey, Loons, what did you have to eat? I'm curious. What was your wheel of choice? What'd you got over there? What'd you get? All right, good to have you guys here. Happy Thursday. Let's keep on going. Okay. So we've made the adjustments. I believe we should be able to do this now. And that should work ideally. Let's find out. Yeah, okay. Yeah, there we go. Okay. Oh, we got a problem though. On line 6, wait, modules.loss. Using a target size of 64 that is different to input size. This will likely lead to incorrect results. Please ensure they have the same size. What do we do? Okay. Some pasta with cheese. Ooh, that sounds very nice, Loons. You got a nice tasty meal right there. Pasta and some cheese. That's the way to do it. I like it. Very nice. All right, I'm getting hungry now. We won't be able to eat until we fix this problem, though. We're not going to eat. We're gonna starve. We're gonna sit here and starve until we fix this. So this will likely lead to incorrect results. Yeah, I know. Why is it using a torch size 64 that is different? Yes. So why is that a problem? Yeah, but we didn't. Okay. 1 second. Let us print out the prediction as well. Print prediction. And let's take a look at this. All right. Prediction. This will be Y. Okay, there we go. Let's get a better picture of the data here. We're gonna figure this out. Okay. So that is a tensor. Oh. Got it. Okay. We're getting a better picture now. Okay. Yeah. So we need to convert these into arrays. So we have to change the shape of this. So as you can see here, there's 64. However, it needs to be 64-1, not a size 64. It needs to be because of classification and how classification works. Yeah, I know. I get it. How do we do this? I believe. Okay, so We can do that around here. Where are we doing? All right, perfect. Right here, right here. Ha ha, ha ha ha. There we go. All right. Now we did it. Now we're not going to get that error. Okay. Save, save, save. All right. Little simple little things. All the little tiny details. Hey, there we go. No errors that time. Making our way. Yep, they're the same shape now. Now we can get into learning, you guys. Now we really can get into learning. Okay. So let's get rid of these prints and let's start the training process. All right. We followed the instructions. From iTryHard helped us yesterday. The user, iTryHard, here. Are you trying using MNIST? Yes, this is Fashion MNIST. So we're using Fashion MNIST here, which is a bunch of pictures of clothing items. That's what we're doing. What time is it where you are? It is 12:56 p.m., so almost 1 p.m. in the afternoon where I am. I'm in Seattle, Washington, United States. What is the purpose of this model? It is a purpose for training. It's computer vision. It is going to be a classification model that is able to identify shirts, bags, sneakers, t-shirts, and dresses and sandals, and a couple other things as well. That's what we're doing. You know LangChain, LangGraph, and retrieval augmented generation. Hey, that's great. You're on the right track. That's something that we need in the world. We need that. Who's that? Who's that? That is Sala. Thank you, Sala, for subscribing. Appreciate it. Thank you for joining in. Good to have you here. Happy Thursday. You joined the right channel for software engineering. We code manually. We struggle. We might turn to the AIs for help to look things up. However, we are typing everything by hand because we're old. We're old. We do things the original way. What kind of project should I make for CV to apply for a job? Computer vision is one of my favorites because it's impressive. You can show what you've done visually. It is very powerful and meaningful from a human perspective. We like to see things. We like to see things with our eyes. So computer vision is always impressive. If it's not computer vision, then you have to turn it into a graph, and then it's like representative abstractly, and kind of hard to understand the value that you've provided. It's better to do a computer vision project. That's my favorite. What's your favorite STT or TTS model, Steven? I can either choose accuracy or latency. I choose low latency models, hits accuracy. Oh, we need a GPU for this, or a CPU is good. Usually a CPU is pretty good. Faster using Whisper. Whisper is pretty good. Whisper is an open source model, right? That works pretty well. I use Whisper, so there you go. That's my answer. Using Kokoro TTS and Kitten TTS. Text to speech. Okay, text to speech. I use speech to text. So as you can see right here, speech to text. We got our subtitles right there. Got our subtitles for you. CPU is usually good enough. Okay, let's see if we fixed it, you guys. Let's see if we got our model learning. My guess is, we ended early. Here we go. Let's fix that. Okay. All right. There it goes. Is it learning? It's learning a little bit, or is it stuck? No, it's bouncing around. Okay. So this model, I believe, will work, though I really want to go back to one-hot encoding. I do. Is it dropping? It is. It is dropping. It is learning a little bit. Is it learning well or not well? It's supposed to go like below 1. Ooh, no, that's a problem. Okay. Yeah, we hit some issues, you guys. We hit some issues. I don't think that's good enough. It is learning, though. It is, because you can see the loss is being reduced. You can see a loss in reduction here. So it started out in the 20s, in the 20s and 30s here, and it dropped down to 9. Okay, let's increase the learning rate. Let's go high learning rate. Okay. Let's see if that made it better. Coding, yeah, I know, right? Coding, exactly. The lollers. Let's see if we can see a good output here. So I think we still have a problem with our data, though. Because I was looking at the data yesterday, and I saw a problem with it. Hello, hope you're having a good day. Thank you for the video attention and activation functions. Yeah, there we go. Thoroughly enjoyed them. Just was curious about whether you're aware of Modern GL. What is Modern GL? I don't know what that is. Did we learn or did we not learn? We didn't learn. Okay. So we are still stuck. There's still something wrong. Let's try to bring this back real quick. I'm pretty sure that won't work because it's not a category. No, it is working, but it's not working because it says it's infinity. It says it's already intelligent. 0 means perfect recall. If you see a loss of 0, that means perfect recall. Hyper tuning parameters takes most of the time. Hey, yeah, that's what we're doing. You know what, Shyam? Yep, we're making our hyperparameter prune. Those good old optimizations that we need to make with the tuning of our hyperparameters. Okay, so we need to do MSE in this case because we're doing a linear output that is going to be one item. One item. I do want to go back to cross entropy though, because I think that we have a problem still. Let's bring this back over here. Okay. Yeah, there's still a problem. So I think, let's take a look over here. I like this song. Amir, good to see you. Welcome on in. Thank you for saying hi. Okay. Vi, fashion, MNIST. Let's go into our training set here. Okay. Okay. CD, fashion, MNIST. All right, LS train is a bunch of images. Okay. Let's open train 9999.png. All right, that is some sort of item. What is that? Zoom in on that. That looks to me like a shirt. What is it? Is that a shirt? You can use regularization with the loss function for better convergence and less overfitting. Good old regularization. Yep, regularization and dropout gonna help us with that overfitting problem. The good news is we're not overfitting right now. What are we doing? Hey, how's it going there, Short Mania? Shorts Mania, welcome on in. We are learning Pytorch, you guys. We're becoming Pytorch experts. That's the plan. We're gonna become Pytorch experts. Join me together. Become a Pytorch expert with me. Fashion MNIST. Yeah, it is. It's, you know it. Deboge. It is. You got it. Deboge. What are we up to today, Shorts Mania? We are becoming Pytorch experts. So this is some sort of shirt item. Hold on. Let me open up our custom data set. Yeah, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? There's 10 items. L train head. 0, 1. 0? T-shirt ankle boot. Okay, number 9. What is, how do we, okay. Love the deep learning. You love the deep learning. Me too. Hey, that's what we're here for. Standeek. Yes, Standeek TV. That's what we're doing. The deep learning, you guys, you know it. YouTube recommended me this very late. Oh, I should have joined from the start. Hey, all good. All good. Glad you joined in here. Don't worry. You're still on the right track because we haven't fully solved the thing yet. We haven't fully solved it yet. So we're going to solve it now. That's what we're going to do. We're going to solve it together. Open train. Let's go into, let's do 10 PNG. That is a dress. Okay, that looks like a dress to me. Okay. Let's also open up 11 maybe? Let's try 11. That is an ankle boot. Okay. This is what, if you never knew what an ankle boot looked like, this is what an ankle boot looks like right here. That's an ankle boot. Hey, Torva, good to see ya. Welcome on in. You're already an expert at most of things, Steven. Well, we want to become even more expert. That's what we're going to do. We're going to become absolute professionals when it comes to Pytorch. We've built many neural networks ourselves from scratch in JavaScript, Python, Rust, and we're going to learn Pytorch to its limit. We're going to learn it to its limit. Okay, so let's take a look over here at this item here. Yep, okay. So all the classes, yep, all the classes are right here. So let's open up 0. Open a CD train. Open this. That is an ankle boot. That doesn't make, is that right? That's not, did we, wait, 5929 was 0. So our ankle boot is configured to 9. We could fix that if that's a problem. Let's look at what another 9 is. Here's another 9 right here. Okay, so if this is 9 right here, let's do copy that, open Nope, that's the same one. Open this one. There's the problem, you guys. There's the problem right there. These two are not the same, although they are classified as the same. One is an ankle boot, the other is a shirt. So our training data is messed up. Right? It says these two things are the same. They're not the same. One's a shirt, one's a footwear. Witness top 1% here. Yeah, thank you. I will take that as a compliment. I think that's great. Appreciate it. Thank you. We're gonna go all the way. Let's go to like 0.1%. Let's go an extra order of magnitude. Let's do an extra order of magnitude. All right, you guys. So if our data is messed up, we can't train. Our data is messed up. All right. Let's look at another 9. Let's go here. Let's try this one. Open that one. See, that's a t-shirt now. See, do those look the same to you? No, they don't look the same to me either. Yeah, we got the elevator music going. Good old elevator music, you guys. So what do we do now? Now that we know our data is messed up, what do we do? How do we take care of this? Is there a way to determine the classification? What is 2? So let's go over here. So this is 1, 2, 3. So is there, does the file name itself indicate what it is? Because the class is broken, but does the file name indicate what it is? Like 10692. Let's open that. Open this. That is a boot. So it ended in 2. Okay. Hold on. All right, these two are the same. They both files end in the number of 2, which means they're both like boots of some sort, right? They're sort of like a shoe. Ankle boot, sneak. Well, technically it looks like a sneaker. I think that looks more like a sneaker. All right, let's find something else that ends in 2. Let's go scroll until we find another 2. Here, right here. Okay. Open that. Is trousers. Okay, so that's not the same. We can't use that. If it starts with the number 2. Okay. So let's try this. Let's try to find something that starts with the number 2. Here we go. Here's another number 2. Open that. Is this trousers? Nope. That's something. I don't even know what that is. What is that? It's not trousers. It must be a purse or something. Okay. So our data is totally messed up. Okay. We have to do something different, you guys. We need to get a different data source. That's why our problem's occurring. It wasn't our model's fault. Our model should work perfectly fine. That's why we were struggling with it before. It was the data the whole time, you guys. Right there. It was the data. Okay. Now that we know what the problem is, we just need to get a different data source. So let me figure this out here. Okay. Different data source. Instead of loading the data from this directory, right? We need to do it differently. You just swap the shoe and the sneaker, or it's all mixed up. It's all mixed up. It's all mixed up. Everything. There's nothing that's good, and there's no way for us to indicate which one is which. Although maybe it's off by 1. Maybe it's like off by 1 or something, right? No, even if it was off by 1, then it would always be the same anyway. So shoes and shirt, yeah, exactly. Shoes, shirts, trousers, purses, handbags are all the same. Okay. So here's our problem right here. We need to get a different data set. We downloaded the data from Kaggle, so it was probably Kaggle's fault. Whoa, what's going on over here? All right. Let's see if we can find the data set here. Let's go into this. Let's just grab it here. Let's just do this. Instead of grabbing it from our local, we're just going to do this instead. Okay. Okay. Training data is going to be here. And this will be our image data set. Like that. And we're gonna hide that. We're gonna hide this right here. There we go. We're gonna hide it. Okay. Target transform. Okay. This should be okay. However, However, we don't know what our output's going to be on the target transform because the D type, can we say D type equals torch.float32? Can we do that? Let's see if we can do that. Before we do it, let's make sure that we haven't broken anything. All right, let's try it. Okay. Do you run your model on a high-end GPU like a large language model? We're running on a regular consumer device. So it's not that powerful. It's not like a super NVIDIA mega $32,000 GPU device. It's just a regular, it's like a laptop processor. It's not that fancy. Okay. Where was the problem? What was the problem here? 2 tensors not defined. Okay. This will be nn torch dot to tensor maybe? Let's find out. Let's double check. Python import torch dot to tensor. Nope. Torch dot nn dot tensor. Oh, no attribute. No attribute. Where is it? Oh, transforms. Where's that at? It would be, oh, torch vision. Is it here? So maybe to tensor. Yeah, right there. Okay, cool. Okay, so that works. Okay. Okay, right there. Perfect. Okay. Were you born this intelligent for your skill, or anyone can these with practice? Practice. It's all about practice, right? There's 3 types of people in the world. Those who are born with a special skill, we're just like really smart. Those who are born with as a normal person, however, they become a really hard worker. It's called the genius of hard work. And there's a 3rd type of person that chooses to do nothing and just play video games all day. There's you go. Okay, you are running on a CPU. I thought you were Pytorch. Yes, we are running. So we are running on MPS. So our device is here. So we're running on MPS. So right here, question mark MPS. Right here. So it is a Mac hardware accelerator. The game, you know it, Fitch. You know it, Fitchy. The game. We are running on an MPS. It is a GPU. It's a GPU. Consumer grade hardware, you guys. On a Macintosh. Right here. So we are hardware accelerated. All right, so we got our 2 tensor. Looking good now. All right. Right here. Defined it. Does it need to be? Yeah, it needs to be like that. Okay. Let's check to see if this works now. Any outputs of happiness? Did we make it work? Linear input weight shape cannot be multiplied 2 by, oh, right. We need to transform it. Okay. Because we did that up here. We did some extra transformations. Like this. So we need to lambda that. We need to run a lambda on it. Oh, where's our lambda at? Lambda. We not have that over here? We need to do some transformations now because we did a whole bunch of stuff. So we did a flatten. Right, we did a dot flatten. So we need to transform this the same way. So that'll be a transform. So we need to define our own transform. Okay, so we will do a decode image. Image transform equals lambda y x. This is gonna be x. Torch dot tensor x comma d type float 32. And then we need to do extra stuff. We need to do a flatten underscore divide by 255.0. I think that does that. I think that's the image transform right there. I think that'll work. I don't know. We'll find out. We're gonna find out. Did we just one line that, one shot that easy? This needs to be image transform, and then we need a target transform equals 1 hot. Eventually, not right now, but we will eventually. Can we do this? Or do we have to do it like this? Okay, let's try it out. Let's try it out, you guys. Must be a real number, not an image. It didn't even make it an image? So, let's see here. Can we say... So X right here, decode image, like that. No such file or directory. Oh, decode image, oh, loads the image, and it's already loaded, so we don't need to do that. Okay. La 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 la, okay. Lambda, X, torch, tensor, dtype float 32, flatten, underscore, divide by 255. That should be perfectly fine. Let's see here. Print. Hold on one second. Dataset. Where is this? Oh, custom dataset. Okay. We got a get item, so we should be able to say print image dataset 0. And then let's see, how do we exit in Python? Python sys exit. I think it's sys.exit. System.exit. So we need to import sys. Okay. Import sys. And then where was that? Lambda. We will go like this. System.exit 0. Okay, let's try that. Exit 0. Yep, there you go. Exit 0. You got it. So, must be real number, not image. Isn't it, though? Let me do this real quick. Let's try that. Okay. Takes positional arguments. Oh, do we need to do this? There you go. Okay. All right. Okay. That's much better. That's much better. Okay, so this decodes it for us automatically. It converts it over into... Oh, it does everything for us. It does the whole transformation. We don't need to do anything that we just did. Okay. So that looks good to me. The only thing is we need to reshape it. So we need to reshape it now. So let us reshape it doing this approach. So that will be 2 tensor x, like this. And we don't need to divide by 255. So I think that'll do the trick now. Let's try it. Good now, good now. Oh, no error. Okay, do we have to execute that? I don't think we have to execute it. Nope. Okay, call, missing argument. Yeah, that's what I thought. Okay. So that should do the trick because it's running through a lambda, right? A lambda x 2 tensor. How about we just do this? We'll keep it clean, keep it simple. We'll just do what it was before. Okay, here we go. Do we have to do something like this? Which is very weird, I know. Hey, there we go. Okay. Okay. That's what we're looking for. Let's see. Okay, so tensor looks good. So now we just need to flatten it. Dot flatten underscore. Okay. How's it going there, Mark Lemon? Thank you for saying hello. You, tensor object has no attribute flatten. Did you mean flatten? Oh. Okay, we'll do that then. We don't need to mutate it, I guess, because we're returning it in the lambda. So there's no need to mutate. So we don't need the underscore. Can't read the complete error because of chat. Oh, hey, no worries. Hey, there we go. Okay, so now it's in the right shape. Now we're good to go. Now we've got it. And we've got the right data. Okay, we got the right data. We converted the model over to using a sparse cross-categorical output rather than a one hot. And we converted to removing some of our activations and changing those out. It should work now. It should work now. What we need to do is we also need to print out the label. We should print out the label as well. And that's number 9. Okay, So label is 9, which is going to be a integer. So we need to transform this into a different thing. Okay. So it's an integer right now. We need to convert it to a float. Let's do that. Let's make that happen, guys. Let's make that happen. Challenge my dream. Thank you for subscribing. Welcome on in. Happy Thursday. Really glad to have you here. We're learning together, you guys. We're going to become a Pytorch expert. We're walking through all the details. We want to now grab our target transform and convert it also to a torch. Let's do that. So I think we could do that around here somewhere. I think we could just, I think we can just do this. Let's try it. Let's try it. Target transform. Okay. Let's see if that fixes it. Because you see right now, it's number 9. You see right here is number 9. I think. Is this also a tensor? Let's double check. This is a tensor. Yeah, that looks good. Okay. Okay. Let's print it out. Let's print it out, you guys. I'm touched. Oh, Speedy Chan, you're touched. All right. That's good feedback. Or just learning. You just turned off by clicking 3 dots on the top right. Oh, right. Yes. So from the chat perspective, when you're on your mobile phone, there's a button. There's 3 dots at the top of the screen. You click that, and it gives you the option to hide chat. So it makes it easier to see. Oh, what? My ID popped up for a subscription. Speedy. Oh, did it? Speedy Chan did it? That was your ID? That was your ID. Top right corner, 3 dots. Click it and toggle the chat to see the screen, you guys. Yeah. So I think that should do the trick. Let's try this. Well, is that going to do the trick? It got a problem. Yeah. Picture should be a pill image or an indie array. Oh, because that's we got to do something different. Okay. Understood, you guys. It's going to be an integer, so we have to create our own. So target transform equals lambda y. We're going to convert it to a torch dot tensor y, comma, d type equals torch dot float 16. 16, there we go. Like that. Okay, let's double check. Yep, that's right. Okay, looking good. Target transform will be this. There. Now we're onto the right track. Let's see if we got it, you guys. Let's see. Every time I say that, we're now the right. Yay, right there we go. Okay. So now it's a float 16, and it'll work with our model, so we don't have to change anything now. What's the time on your end? We are currently at 1:23 p.m. in the afternoon. Good to have you guys here. We're currently getting our AI model to work, and that's the whole goal for today. If we can get it to train and it works really well, and get the loss below 1. Can we do it? Do you think we can get the loss below 1? I think we might be able to. We might be able to. All right, let's give you a poll. Let's see what you guys think. Let's see where we're at right now. Can we get AI loss below 1.0? Question mark. Yes or no? Let's get that poll going. I'm curious what you guys think. I think maybe. I think we might be able to do it. Hey, Steven, I try hard. Hey, we implemented your suggestions. I try hard. We did. Welcome on in. It's 9 p.m. in France. Oh, well, it's not that late then. It is bedtime. That is bedtime for sure. 9 p.m., that's bedtime. Oh, did it help? It made it different. We found another problem though. The data. It was messed up. The data that we had, the categories were all jumbled. They were randomized, so it wasn't learning. We downloaded the data from some random Kaggle dataset, and it was miscategorized. So the data was broken. 9:25 in Spain. Getting late over there. Is it just me, or does the music make it funny somehow? Does it? Yeah, this is the YouTube music library, you guys. We got the music YouTube library. I like it. I'm happy with it. It's free, and we can play it on stream, and it works. It's Creative Commons. Oh wow! At least we got the loss function sorted. Yes, so we changed the loss function. So this doesn't work. So we couldn't use cross entropy loss anymore. The cross entropy loss only works when it is a one-hot or a categorical output, and the outputs were 10. We changed it to a 1, so it's sparse cross categorical, which is okay when the numbers are small, right? Below 10, 1 to 10, okay. Maybe 1 to 50, okay. Anything more than that, you're pressing your luck with AI. AI likes numbers between -1 and +1. That's where AI likes numbers. If you play around with numbers any other way, you're running into potential issues. We're running into potential issues. All right, so we had to make a few changes. Let's get going. All right, I think we're good to go. So we're loading the data direct from a known, good, trusted data source. What could be the potential issue? So the original issue that we found that was the real core of the issue was the data was broken. It was wrong data. Isn't MSC loss used for regression, or can it be used for classification? Yeah, it's regression and classification. You know why? Because you told us to put our output to 1. It's no longer 1 hot. It's 1 value. So MSC works perfect. And in Pytorch, it won't let us use a cross entropy when the output is 1. So we had to change it to MSC. There's no other way to do it. And why don't AI like numbers out of... it's just how the math works. If you go beyond... And how float numbers exist, and the number of bits assigned to the floating values, you reduce your bits when you get to higher numbers. And those bits do not contrast well with the weights of your model, which are always initialized between 0 and 1, kind of around that range. So that's why you want to keep your numbers small. When you see things like a division, let's see here, 255. Like, see how I'm dividing by 255? That's because the image pixels have a color range between 0 and 255. You need to normalize that down to a number between 0 and 1 to give it. Otherwise, you have things like exploding gradients or collapsing gradients. That's why, you guys. Learning rate, yeah, that's another way to look at it. So you could gotta have a really low learning rate if you have your numbers too big. Speedy Shan takes, like, when you have a range of data, that data is normalized between -1 to 1, so it's easier to calculate. You got it. Okay. So I think this is good to go. Let's hide that. Everything's in the right shape now. We're converting it to what we want. Okay. Can we move this over here? I'm curious if we can do this. Let's try that. Just to clean it up a little bit. Okay. Is it gonna work? Is it gonna work? Ooh, hard crash, you guys, hard crash. Okay. Ignore. That didn't work very well. Whoops. Okay. Let's bring that back. Why'd that hard crash? Why is it that -1 less than n less than 1 and not 1 less... is that great? No, less than n less than 1. What do you mean, Benedict? What do you mean, Benedict? I don't understand. You gotta tell me more. Hey, Jack. Bro didn't say negative. Oh, yeah, you can do -1, right? Because tangent, tan h, -1. It can be -1. Yeah, so check this out. So -1 to +1, right? Those are the good ranges. That's where AI likes it. So it could be -1 to 0. That's fine. And it can be 0 to 1. That works as well. This is where it likes it, right here. That's it right there. Right there, you guys. That's the good range for AI numbers. You like it. You sound like you're saying oh, yeah. We're not though, Jack. We're not. Benedict, depends on what your normalization function is. It sure does. Got your normalization function there. You just realized that. Got it. Okay, so we have a problem. What was the issue? All right, so let's say return here. All right, let's load that. All right. And will we get a problem here? Is that where the problem is? Yeah, okay. All right. Ignore. So we've got a problem right here. Let's find out why. So let's return this and let's do print y and figure out what our problem is. And let's also print prediction. Oh, you know what? We've already got that right here. Okay. Okay. Let's see what we got. Always use sigmoid. Oh yeah, sigmoid's a really good one. I like sigmoid. That's one of my favorites. I like tan h. Tan h is one of my favorites. So what was this here? Oh, whoa. Hold on a second. Okay, so oh, we got a problem, you guys. I see it. I see a problem right there. Do you see the problem? I see it too. TensorFloat 16, and it is a, we don't have a D-type on that one. Can we do a D-type on that? Did we miss a D-type somewhere? I wonder if we can say D-type here. D-type. Can we do this? Well, that's the output though, so I don't think that matters. Okay. Maybe put a try except log error. Oh, yeah. Oh, good. It crashes anyways. Don't worry. We're doing a hard crash here. The actual whole system's crashing. If we try except on that, Python won't live. It won't live through it. It's a hardware mismatch. It'll crash regardless. Good news is though, we're not broken yet. We're not broken yet. We know what we're doing here. We got a plan. We got a plan, you guys. Okay, so where is, all right, so this is not, so the prediction on the output. Okay, no worries. This is where we need to fix it right here. We got to fix this here. So can we, how do we do this? Do we do it over here? Target transform. Can we do this? Is that going to be better? I think that might be better. Maybe. Let's find out. Did we get it the right shape this time? Yes, there we go. Now we're in the right shape. Okay. So that is a float point with the categories in the right same shape that it needs to be. Okay, perfect. Perfect, you guys. I would like to convert this over to a, where does this at? Can we do, I want to do a D-type. Oh. Uh-oh. Are you guys still there? Okay, good. Okay. Had a little bit of some weird things going on. Hold on a second. H-top. Yeah, we're fine. Okay. I want to grab this and see if we can do this. This is on the image transform. Can we do that? Is that possible? Will that work? Nope, doesn't like it. Okay. What if we put it over here? Will it be okay here? We don't have to. I want symmetry. Okay. It's not letting us do that either. Okay. Okay. So we've got something that works, I believe. That looks correct. The prediction's got the correct output. It's just a very big floating point number, and I don't need it to be that big. Why don't you stream normally on YouTube instead of YouTube Shorts? So we do have a... Oh! Zoe, how's it going? Hi! I missed your message. We also have a... What do you call... A Twitch going. So let's see here. Channel. So you can see it's right here. Channel. So you can see it's right here. We are on Twitch as well. So if you want, you can go over there to get the whole... Hello! We used to, mostly we're here for YouTube though. We're here for YouTube. So if you want the horizontal experience, we're over there on Twitch. The good news is, here at some point, YouTube did say that they're going to fix, they have a problem. There's a problem. There's a known bug right now in YouTube where when you do a dual stream, it does something that is not good. It does something not good. I have set up the ability to do a dual stream. I have. However, if I do it on YouTube directly, it has a bug. They've acknowledged that there's a problem direct from the engineering team. So we can't stream dual on YouTube right now because of the problem. They say they are looking to fix it. And they've been saying that for a few weeks now. Actually, it's been a few months. So it's probably going to be a while before they actually fix it. So if you want, we're on Twitch. So you can get the full screen experience if you want that. Okay. So, did we get it correct? We are good. All right, let's try doing a loss now. Let's try doing a loss. One loss, you guys. Let's try it. Let's print the loss. Is it going to work? We're going to find out. It crashed again. No! No, why? Oh, float. Okay, so 16 to 32. So let's read through this. Op requires the same element type for all operands. Okay. So we do need to do a data transfer conversion. It's mandatory. What are we doing today? How's it going there? Braun, good to see ya. Welcome on in. Are they trying to vibe code fix it? I know, right? They probably are. They know what the problem is. They just don't know how to fix it, is what it really is. They're not sure how to, because it conflicts with another thing. So that's why. It conflicts. It conflicts. So that's why. The short, yes, exactly. Better discoverability than normal ones, which is why, yes. So that's also one of the reasons why it's part of the picture. So once they fix the actual problem, then I will do a dual stream on YouTube. Also, they don't share the chats. The chats are split. So I'd have to figure out which chat you're coming from. Okay, so I know if the problem's here. So what I could do is I can change the prediction. I can just straight up change the prediction. I would rather change the X directly. So that way the output doesn't break the graph. Oh, you didn't know about that? Yeah. Oh, yeah. It's real. It's real. It's real. Okay. We are almost there, you guys. We're almost there. I want to, this image transform. I do want to convert this. Let's do torch.tensor. Let's try this. dtype equals float 16. There we go. Let's see if that works. Let's see if we do that. I think that should work. No. Float 16. Oh. Torch. FLO float 16. There we go. Okay, let's try it again. You gonna crash again or what? Yeah, a different kind of crash this time. So it means we're making progress. Ron, didn't answer me, huh? What are we doing? Oh, so we are going through all the Pytorch tutorials. Every single Pytorch tutorial, and we're gonna become a Pytorch expert. Let's do it together. Every single tutorial we're going through. So that's what we're currently working on right now. We hit a bug in the actual tutorial itself, and we're trying to walk through it. The actual code, maybe it's because I'm running on a Mac, right? I'm running on a Mac, and I'm using MPS, which is the Metal framework for hardware acceleration. And that's probably why we're hitting these issues. So let's find this out. So using MPS device, warning, copy construct from Tensor is not recommended to use source Tensor destination clone. Oh, rather Tensor source Tensor, rather than, oh. So we have to break, oh, okay, detach clone requires grad. Okay, so instead of doing this, we have to do it different. Okay. Seems okay. We can do that. Although, all right, let's try it. Let's try it, you guys. Okay. So let's do this. Okay. Source tensor.detach.clone. All right, let's do this. Where is that? Right here. Okay. So this will be .flatten.detach.clone. All right, see if that does the trick. Nope. Okay, ignore. Okay, let's do it differently. Okay, did we do this? Is this right? Are we doing it right? Are we doing it right? Yeah, let's redo this. Let's redo this. Okay. Okay. Let's try this. Let's try this. All right. I think that brings us back to where we were, where it was kind of working before. Let's double check. Let's see here. Emmy, didn't see you. Our training and image recognition. Oh, right. Torva, thank you. Appreciate it. Thank you for describing it. Yeah. That's what we're doing. So we are going through all the Pytorch tutorials. Currently, what we're doing is training AI on an IMIS dataset, which is a bunch of pictures of clothing items. We're going to train an AI to recognize each of these categories. And we're trying to get the data in the right shape. Hey, MD, good to see you. Welcome on in. Happy Thursday. I like how keeping saying making progress. When you get an error code, I wish I could be excited about debugging. Yeah, we are. We're getting different errors every time. Every time we're getting different errors. So I've got another approach. We should be okay. Okay. So let us convert this tensor here to the same tensor. Although it is already on an MPS device. So that's part of the problem. That's why I wanted to do this up here. Let's see. Oh, clothing MNIS. Yeah, exactly. Already moving fast. Yep, Dina, you got it. We're moving fast, you guys. We're almost at the end. So the plan is before we end stream, we're going to get an AI that works. Right now, if I run this, it's going to crash because it's not the right data type. So it is a float 16. Let's see here. Maybe what we could do is we can update the other one. So what 64.1 F16 to a 32. Okay. So let's turn it to a 32. Instead of a 16, let's do a 32. Let's just change it up here. Right here, 32. Let's just do that. Now it's going to be the same, right? Now it's the same. Hey, there we go. All right. Wait, maybe? Yes. Okay. That was it the whole time. Did you see that? Was that anywhere in the tutorial? Float? Nope, not even the word float was there. And that was what fixed it. Maybe. There, we got this. You know it. All right, I'm really excited now. All right, let's comment this stuff out and let's see if we can get it training. Did we do it? Did we make it work? All right. Here we go, you guys. Moment of truth. Here we go. Is it gonna work? Hey, there we go. Look at that. We did it, you guys. Right there. All right. That's what we're looking for. So now we need to get the loss below 1. Maybe we can get the loss below 1. We're really close. We did it. All right, default to float 32. You could just leave that out. Dina, if we don't, we have to, because otherwise it's an integer. YOLO. Yeah, we did it. Hey, Savon, good to see you. Welcome on in. Thank you guys for the party poppers. The default will actually convert it to its native type. We tried. It keeps it as an integer. So when we had to do the conversion, because otherwise it gives us a fully different kind of error. All right, you guys, we made progress. Yep, see, it learned. It went to 25.7.1. Now it drops down. All right, so let us get this back. Okay, let's try this again. Ending of stream near. We're getting close. We've got one more objective, you guys. Let's get that loss below 1. Let's get it below 1. Let's try. Hey, there, it's below 1. All right, I don't know if that counts or not. But here, it dropped below 1. It already did. Let's see if we can get it consistently below 1, though. I think that's a good idea. That's the goal right there. Right there, you guys. We did it right there. We did it. Okay. What is the fix to make it learn eventually? We had to do a lot of things, Savon. A lot of stuff was broken. A lot of things were broken. First off, the major thing that was broken was the data set. This data set was a complete mess. It was a complete mess. The categories that were assigned to each of the images were broken. It was random. It was like jumbled. So that was a big problem. I downloaded that from a zip file from a random Kaggle dataset that was like 7 years old. We should have stuck with the tutorial. We should have. And then we had to reconvert everything. We had to retransform everything in order to get it to work on my Mac processor. And we removed cross entropy loss because it's a sparse categorical. It allowed us to use a linear output for linear regression, and it converts the output to essentially what would represent an integer, right? So we can round to the number. Garbage in, garbage out. You know it, exactly. Hey, the last attack, what's up? You made it in, we figured it out. So the fix was a lot of things. We did a lot of things. We had to convert the input type, the data was wrong, the conversions, the transforms. We had to do custom transforms, right here, custom transforms to get it working. So you said the data type, let's try this real quick. Defaults to float 32. Let's see, we'll test it. We'll test it real quick. Just to see if you're right. Are you right? Are you right? Yeah, see, we had to convert it. We had to convert it right there. Right there. Dina, if we don't convert it to float 32, it errors out. So we have to. It's mandatory. It's mandatory. Now it looks good. There we go. Machine learning, 99% data. The rest is sweat. Exactly. It's all about the data, you guys. You love system development, MD? Me too. I love developing systems. The kernel development AI said you should learn computer architecture and then should study operating systems. Some advice from your perspective. Sure. Operating systems is pretty straightforward. I don't think there's a lot there. There's usually in an operating system, you can call into the OS with a set of functions, right? It comes with a set of functions. I/O, the ability to request an integer ID to transmit data to and fro. You can open data on a disk. You can open data on a network. So the system is pretty easy. I don't know if it brings a lot. I don't know if it's necessary. You recommend learning MNIX. Oh, what is MNIX? Savan, what is MNIX? Tell us more. Tell us more about MNIX. Garbage in, garbage out, you guys. Okay, so we got it below 1, which technically, if you said yes on the poll, you got it right because we got it right here. Right there, we got it. Okay, so what we could do is, we got 20 minutes. Stephen, operating system theory is philosophy is quite good. Is quite good. And is philosophy. Yes, it's worthwhile. Don't get me wrong. Oh, that's what MNIX is. Got it. Okay. Good. All right, Savan, thank you. Thank you for correcting. I appreciate it. Okay. So, yes, good. Nice. How you doing? Hey, how's it going there, Edwardian? Edward Ian. Is it Edward? I'm good to see you, Edward. I would say, call you Edward. It builds your process thinking. Nice. We're doing good. We figured out the problem. Our AI is learning now. We actually got it learning. It's actually learning. Let's see if we can lower the loss slightly. We'll go down to 0.1. All right, let's lower the loss. And then we'll increase our epochs to 8. Okay, there we go. See if, yeah, see now it's dropping a little bit more slowly, although it's gonna find more of a local minima rather than global minima because we're not jumping as much. We can also change our optimization function to bop in a little bit more rapidly. Yeah, see, it's not going below 1 now. Okay. So let's jump up higher. Let's actually increase this. Let's go a little bit higher. Like that. Autocorrect is killing typing. No worries. Linus Torvald, operating system is a professor. Hey, much better. All right. I like this. A whole bunch of zeros in there. Nice. Okay. We did it. So what we should do next is, now that we've got about 10 minutes? No, wait. About 15 minutes. We got about 15 minutes. Thanks for the advice. Yep, Savan's got great advice. Really good advice. Good book recommendation. Okay. So now that we've got something that's pretty good here, let's actually increase this to 1. Let's see if we... No, we can't do that. Let's do... What did we had it before? All right, we had it way down there. All right, let's keep it here. Okay, looks good. I would also want to bring this back. I kind of want to bring this back. I want to try this. We're going to mess around with this. We're learning together. I think we can get this to work. So I want to use argmax, you guys. I want to use argmax. Okay, so this will be 1 hot. Tensor, torch, tensor, 1 hot. That should do it because we're going to use zeros, scatter, torch tensor's value 1 hot. So let's try this. Target transform is going to be 1 hot, like this. All right. I think that should work now. Okay. What optimizer are we using? We are using the stochastic gradient descent. So very basic one, a very basic one. It's my favorite. It's the one I like to use. We could change it up though. We can change it up. Cross entropy will work. Just don't one hot the input. Oh, we have to though. Well, all right, you know what? We'll try it. We'll try it your way. We'll try it your way. We won't one hot it first. Here, we'll remove the one hot for now. It might not work though. Just get ready. It might not work. If it does, we're learning. I see. Okay, there's a problem. Multi-target not supported. The cross entropy. Yeah, see right here. We have to one hot it. We have to. It doesn't work otherwise. I think I could be wrong because if I change it to one hot and it still doesn't work, that proves that I'm wrong too, right? Ouch. I know. It might be a Pytorch thing. It might be a Macintosh thing. Paste in Discord for the benefit of the audience. Thank you, Savan. Appreciate it. What do you think about the chances of AI making human coders obsolete? Microsoft is already swinging that direction, unfortunately. So here's what it's going to be. Everyone's going to be a coder. Everyone's going to be able to talk to the computer and have it write applications. Here's the deal. Only a few people in the world really kind of like doing that. Not everyone really likes doing that. If you're a software engineer and you want to use the AI to paint the pictures for you, paint all the words on the screen in large brush strokes, you're still a software engineer. You're still a software engineer. And everyone can do it. That's fine. You still need someone there driving it to bring value to the world. So I think what we're going to see is an explosion of software engineers. We're going to see the demand increase dramatically. And we're only creating the demand right now, this very moment. Everyone is writing code, and it's okay code. It's going to be maintainable only if we have the people to maintain it, and that's you guys. That's you guys. Thank you for the heart. Appreciate it. I got reminded today of the Mode 13th interrupt. The 9064 ASM demo scene. Those were the times. Ooh, are you talking about really cool visual stuff? I actually kind of forgot about that. Mode 13th interrupt demo scene. Let's check. I'm going to look that up. I'm going to look that up, Savan. I'm going to look that up. All right. Let's check that out. Images. Is that what I was thinking it is? Is it pretty stuff in here like this stuff? Am I looking at the right thing? Is this it? What file you love the most engineering now? Like operating systems, or are interested? Nothing interesting there. Oh, visuals, ADB music demos. Yeah, that's what I thought you were talking about. Yeah, the really cool, like really fun looking, like wavy things. Yeah, exactly. There you go. Odd, very odd. What file you love most in engineering? I'll try to send some links. All right, sounds good. Send the links away. Okay, I try hard. What we're going to do is we're going to go back and we're going to add back the one hot here. One hot. Like that. And it might magically work. Is it? Is it going to magically work? And look at that. It magically works. Check that out. Hey, and the loss is going the way I want it to. See how it's constantly decreasing? Oh, it looks so much better. Now I can use argmax. Yeah, look at that. All right. See, I told you. I told you we had it right. I try hard just to let you know. We learning together. Boom. That was the answer. We had it right all along. It works. Look at that right there. And we custom hand coded this. We made this work the way we wanted. Right here, target transform. The one hots, all of it. Guessing I was, no, hey, you know what? It's okay because the AI got it wrong too. The AI thought that was a problem, and it's not a problem. So it's not your fault. You get information, right? It's all about the data. We learned. Hey, we did it, party popper. Yeah, thank you guys, appreciate it. Check this out, isn't that great? All right, now I'm feeling just relieved and satisfied, overwhelmed with joy because we fixed it, you guys. We fixed it. Get status, get add custom right here. And then we're going to say get commit dash message. And we're going to say, we fixed it. Party popper. There you go. Let's do a couple more party poppers right there. Right there. Wait, yep. Oh, yep. Oh, wait. Oh, hold on a second. I clicked the button. Oh, yeah, we can't do that. No. 1 second. Let's clear that off. Oops. Let's retype that. Oh, wait. I was trying to copy paste the party popper, and then I got over. I went a little crazy. There we go. Done. All right. Easy. One party popper is fine. What are you creating? How's it going there? Matterixon? Can you say you're Matterixon? Matterixon. We're going through all the Pytorch Python tutorials that are available on pytorch.org, and we're going to become experts together. We just hit a massive milestone doing the computer vision successfully. We did successful computer vision. Oh, hey, Assad, thank you for subscribing, Assad. Appreciate it. Thank you for joining in. You joined the right channel for software engineering. We successfully got it working, you guys. Look at this. Yeah, I'll show you. So this is our training. So let's rerun that command. Let's see here. We're going to call it custom. Python custom. There you go. Here's the answer. So what you see here on the screen, what you're seeing, these numbers on the screen, you want the loss to decrease because that means the model gets more and more correct over time. And since we've got the correct model for the kind of data that we're using, a classification challenge, we are getting very, very good results. Oh, I love it so much. Look at that. That is great. And we should also be able to add back an activation. We should be able to add this in. Now let's add in sigmoid because it can be between 0 and 1. We don't want any negative numbers. We don't need it. So let's try this. Let's see what that looks like when we add in sigmoid, you guys. We're trying sigmoid now. Is it going to make it better or is it going to make it worse? Well, it might need a heavier learning rate. It is learning, just not very quickly. So let's bump up the learning rate slightly. That's what we're doing. That's what we're doing, Matterixon. We are, try Adam for optimizing. Maybe it'll get better loss. All right, let's try Adam. We'll try Adam. We'll do that. We'll do it. Live captions just said bad word. Uh-oh. Did it? Oh, it mistook us. We should probably add in a filter because we wrote this software so we can control it. We should add a bad word filter. Don't tell me what it said because you'll get moderated. Well, we are creating the MNIST training dataset. So this is the fashion MNIST. So what we've got here is a bunch of pictures of clothing items, right? And their associated labels, t-shirt, sandal, dress, bag, sneaker, whole bunch of different items there. We're training the AI to learn to recognize these photos. That's what we're doing. That's what we're doing. Steven, did you get any feedback from your question from yesterday? Yes. Did I? Oh, I did. I got the answer. Okay. I got the answer. Do you want it now? I can tell you on stream if you're interested. And I can make it vague. So that way no one knows what we're talking about. I can make it vague. Only you and I know what we're talking about. I just say yes or no. I'll make it vague. I'm so grateful to meeting you. Oh, Bron, it's great to hear. I'm going to be so good at coding in a couple years. Studying CS. All right. Just DM. Okay. Just DM. Okay. We'll send you a direct message. Got it. Thank you for the hearts, you guys. Bron, appreciate it. Appreciate it. Thank you. So let's try a different optimizer. So let's do Adam W. Adam W. Is that the one? I try hard. Does that sound good? Thank you for the hearts, you guys. Appreciate it. All right. Here we go. Adam W. Hey, look at that. Ooh, that's looking good. Okay. Is it going to pop down more or is it stuck? Okay. That might be because of our sigmoid. That might be your sigmoid problem because it's dropping down and it's not. So what we need, let's do a 10H. Let's do a tangent. Let's do a tangent, you guys. Thank you for the party poppers. 10H. Like that. Can we do that? Is that better? Okay, let's try that. Let's try 10H. Hey. Yeah. Oh, now we're cooking. Now we're cooking. Look at that. Oh, that is good. Oh, it's so good. That's what you want to see, you guys. That's what you want to see right there. And we could probably change the learning rate a smidge. Let's see. Let's bump this up to a 1. Let's do that. Let's go 10x higher. Let's go 10x higher. Let's try 10x. Let's try 10x. Adam has momentum, which makes it increase and decrease. All right, so that's too big. All right, we made the learning rate too big. We'll need to shrink that back down. or decrease learning depending on how your model is learning. Got it. Okay. All right, that was too big. All right, let's drop that down there. Let's go like that. Okay. Do we want to make a sensor just like something actually censors them, or that it takes the THs so it doesn't think that it's actual word? Oh, similar sounding. Got it. Yeah, we need to do something. We need to do something. We could come up with some ideas because it's open source, right? It's open source. Ooh, look at that number. Okay, so we've got good results here. We got really good results. Can we make it go further? What if we increase the units? Let's go up to, let's go 784 units. Let's do that. Let's do 784 units. Let's make it bigger, you guys. Let's make it bigger so it can learn more details. What else is Pytorch useful for besides image recognition? So you've used ChatGPT, right? Right? You've used ChatGPT. It's also good for video generation. It's good for text generation, right? It's good for image generation. So it's good for generative AI. You can also use it for deciding things. So it can be a decider, right? Classifier. Those are Adam's JavaScript. Pasted some links for the 13th Discord. Thank you. Thank you for the links. Demo recording that our era, unfortunately. Hey, no worries. All good to hear it. So Torva, yes. I think we need to do something for the subtitles. We need to add that. Maybe that'll be a good project. Maybe that'll be a good project that we can do. We can upgrade it so that way it doesn't have any bad words in it. We can do that. Okay, you guys. Adam W is the de facto optimizer for transformers, by the way. Hey, good to know. Good old Adam W there. Okay, so let's drop this down to 256. Let's see if dropping it makes better. Sometimes going the opposite direction makes it better. I try hard, yeah. Let's see, is it better? Oh, it's actually fine. So 256 is pretty good. It gives us about the same results. So we're perfectly fine. What if we got rid of the tan H here? All right, let's close that. Let's get rid of the tan H. Okay. Let's see what it looks like that. Oh, now we're cooking. Okay. What do you know? All right. That was way better. All right. Apparently, you don't want your activation on the final layer when it's very simple like this. Okay. Now we're cooking. Ooh. That's the kind of victory I'm looking for right there. I like that. Okay. We're learning together, you guys. Right here, look at this loss. Oh, so good looking. Right there. Ooh. Fantastic. Edward, yeah. Yeah, right there. I like that. That means it learned, you guys. That means it learned really well. Okay. Let's print this back up here. Let's go. 512. Let's double it. Let's double the memory. Let's double the memory. Okay, let's try it again. See if we get anything good. I'm late. Oh, hey, the cooked. Don't worry, you're doing good. We're doing good. Look at that. It's about the same. Okay, it's about the same. So what you want to do is you want to have the lowest number of units, so that way you because if you just keep adding units after a while, it doesn't really matter anymore. What you can do is add a few more layers, and that does have diminishing returns usually after the 5th layer. So let's try adding. Ooh, it is learning better. It is learning better. Okay, so let's add a few more layers, you guys. Let's do that. Let's go right here. 1, 2 more layers. All right, so now it's a really dense matrix. I'm gonna head out. It's 2:30 a.m. All right, I try hard. Thank you. Thank you for helping me on Discord. We made it. We got it working. We got it working, you guys. It works. Good to see you. I try hard. All right, we're wrapping up here, you guys. We're gonna wrap up here really quick. We're not done yet. We're just gonna mess around with this a little bit more. Tomorrow, oh, look at that. That's so good. Oh, it's just so good. Okay. Tomorrow, the plan is we're gonna run a testing phase over this data. So that is the follow-up to the training phase. Once you've trained your model, you want to test it. You want to test it on data that it's never seen before. Data that's never seen. So I'm noticing here that it can't learn anymore, even with the additional layers that I've given it. Although it does seem to be doing a pretty good job. It is a pretty good job there. Hello, I've come across your stream a few times. Do you only do Python? Hey, Jake Happel. It's good to see you. Welcome on in. We do Rust. We do JavaScript. We do Golang. We do, I guess we could do other things. Those are the ones in Python, right? Python's usually. The ones that I like the best are Python with AI. That's my favorite. That's what I like the best. I like that the best. So yeah, Jake, lots of them in there. Is there a huge difference in the paid version of AI chat models and the free models? Don't know much about this stuff. So Matterixon, the idea is when you pay for ChatGPT, they do give you access to the more intelligent models without as much limitation. So yes, you do get better. It is better to pay. Right now at least. And you can download models that are pretty close to the frontier models. ChatGPT, Claude, Opus, and then Codex with the ChatGPT, and Gemini. Gemini is probably the best one you can get that's free, and you get the frontier model. So if you go with Google's model, you're gonna get probably the best experience without payment. So it's the best free model, I think. There you go, you guys. We did it. Okay, so we don't need these many layers. We just don't. It seems like this is enough, and we can also go down to 256. And that will give us plenty. What you make in system model? We are making a model. So we built ourselves an AI model that is able to recognize images. So you guys see here, we've got a bunch of pictures of images, and our AI will train on those using these labels. These labels are like dress, t-shirt, sandal, shirt, sneaker, brag, right? You've got all these different types of clothing items and accessories. We've trained a model on this, and we've succeeded. So I do see a slight improvement. When we have a little bit more memory and when we have one extra layer. A slight improvement. I would like to add this as tan-H here. I want to do this as tan-H all over. So let's see if that gives us even better output. Because the problem with ReLU is going to deactivate some of your neurons in the feed forward. You're going to lose data. So I think it's a potential that we'll have an improvement. We might have an improvement here. Let's try this. Let's see if it works better. Or otherwise, we'll just go back to ReLU and we'll keep it simple. Neural network or HAR? Hey, David Bailey, what's HAR? What is HAR? Let's see. NN versus HAR. What is that? HAR cascades specifically Viola Jones? Neural networks and convolutional neural networks are both used for object detection. They differ significantly in speed, accuracy, and computation requirements. HAR cascades are generally faster, making them suitable. Oh, hey, who's that? Jake? Hey, Jake, thank you for the subscription. Appreciate it. Welcome on in. Happy Thursday. We're learning together. I thank you a lot. I didn't know about HAR cascades. I'm not familiar with this. For real-time applications, lower power devices, neural networks, especially convolutional neural networks, offer superior accuracy, especially in challenging lighting or occluded objects. What is this word? Occluded? Just to tell you, Claude T9 programming, Claude 4.6, no mistakes. Yeah, exactly. No mistakes. Let's take a look at the feature table here. HAR cascades are extremely fast, while neural networks are higher accuracy and robust. Real time often requires GPU, moderate struggles on angles in occlusion, and the accuracy is very good here. Okay. Resource usage, very low. High resource usage for neural networks. Okay, that's kind of neat. I didn't know about this. I'm always like into the extreme performance. I really like that. I think that's neat. However, I also want it to be accurate. It's got to no mistakes. It's kind of Windsurf uses cascade agents. Oh, really? Look for an image. What image is that? I will click the image button. Image on HAR cascade. I don't get it. Okay. So good for image detection. That's very fast. Very fast image detection. Okay, so it's very good at finding like faces and stuff like that. Divide squares into some squares. Yo, Steven, how's it going there, Michael? Michael, good to see you. Welcome on in. Happy Thursday. Okay, so this is really good for simple object detection. Got it. Okay. All right. In this case, this is like object detection in a scene, and it kind of doesn't, it just does, bounding boxes. We're actually trying to go a step further and identify specific objects, right? Very specific objects. So that would be right around here. So here we go. We want to identify these specific objects. Okay. So I think we achieved our objective very well. Very well. Good objective. So we can go back to ReLU. Go back to ReLU, single line, 512 is good. Let's rerun it to make sure that we're looking good here. And then we're good to go. We did it, you guys. We succeeded. We got it below 1. We got the last below 1. So I feel so behind. Anything Pytorch that's not a transformer. Oh, yeah. It's a lot of stuff. There's a lot to it. And we're going to learn it all together. That's the plan, you guys. Thank you so much for joining me today. I'm headed out. I got to get going. We achieved the objective. Tomorrow is Friday, the last stream of the week. We will be live on Monday, of course, every weekday. Tomorrow, we're going to go over the training. We're going to go over the output from your training over into testing. So we're going to go into testing now. Where's that at? Right here. So this is optimization, and we're going to be doing testing, which is the evaluation, the test loop. We didn't do this today. We will do it tomorrow. David Bailey, cool, see ya. Yep, it's been a pleasure. It's good to see you guys. Torva, we're headed out now, you guys. It was a lot of fun. We got the goal. We figured it out. We figured out what the problem was. We fixed it. It only took 2 hours. Well, a little bit less than 2 hours. We did it. It was good to see you guys. Thank you so much. Ever used F#? Yeah, functional programming. F#, right? So C#, except for cheers all. Just joined. Oh, loading. Hey, loading. Yep, we'll be back tomorrow. Don't worry, we will be back tomorrow. 2 hours not a lot. I know. Well, actually, it's okay. It's okay. I want to look. Now we're used to the AI coding agent might have solved it immediately. Bye, Edward. Good to see you. Stephen, I just had my CTO use AWS Labs MCP with Claude to set up an entire data pipeline. What do you think about the future for the job market? Oh, hey, it's okay. It just means that we're going to be focusing more on building and developing apps, right? That's what we're going to do. We will spend less time on setting up production environments, less time actually typing out the code, right? Things type out faster. We still need people to drive it, you guys. You're still there. Hope you all have a fabulous rest of your day. Thank you, Torva. It was good to see you guys. Bye, everyone. We'll be back tomorrow. See you until then. Bye, guys.